Today we're going to learn about the concept of a limit. So it's about limits. So if we want to start our discussion on calculus, we're going to have to familiarize ourselves with the concept of limits and the notion of limits and what limits actually are. Because limits are super important in calculus as they help us develop the fundamental key concepts that calculus is based on. So what is a limit? So let's say we had a graph of f of x. Can you draw these axes? Okay, x, y. Okay, so we have a graph for here. And this is our graph of f of x. Okay, so you could see from here that, let's call this number x equals c. So at x equals c, the function f of x is not defined at c, so it's not necessarily defined at c. However, you can find what is known as a limit. So if c was defined, what would c be? But a better definition is what does, as x gets closer and closer and closer to c, as x approaches c, what does f of x approach? So if I were to, sort of zoom this in, okay, if I sort of zoom this in, okay, so I'm just gonna do all this unnecessary stuff. Well, this is C. This is like you're starting to get closer and closer and closer and closer to C. And you see that, let's say this number is n. Well, you start to get closer, the y value starts to get closer and closer to n, although the function never actually is n, because f of x is not defined at c. And you could do the same thing for the other side as well. You could start to get closer and closer and closer and closer to c. The function will never actually equal c, but we're just trying to see what it approaches. Okay? So a good example of this would be this function. Let's say we had a function f of x equals x squared minus 5x plus 6 over x minus 2. So let's say we had this function f of x. So if we were to make a table of values, you'd use a calculator. This is x, this is f of x. So our function is not defined at 2, because if it was, then we would get a denominator equal to 0. So let's put 2 in the dead center. So input does not exist. Okay, so it does not necessarily exist, but what happens is x approaches 2. Well, let's start with 2.1 and 1.9. Okay, so we're already starting out quite close to f. So if we were to put this in a calculator, you would get okay, so you would get negative 1.1 Now let's see what we would get if we put 2.1 in here instead. Squared minus 5 times 2. One plus 6 divided by 2.1 minus 2 is 0. 1 minus 2 is 0.1. We would get negative 0.9. So let's go even a step further. 1.999 and 2.001. Okay, so do this. So let's plug this into our function. Okay, so let's plug in negative 1.001. And if we were to do the same for 2.001, we get negative 0.999. So obviously, even though it does not exist at 2, as we get closer and closer and closer to 2, you start to get closer and closer. Well, negative 1.1, negative 1.001, and then from the right, as we're approaching from the right, we get negative 0.9, negative 0.999. So we get it approaches negative 1. So that would be the limit. So this is a notation. The limit as x approaches 2 of f of x equals negative 1. And we're going to end right there. So this would be an example of our very first look at limits.